Hello YouTube, and anywhere else you might find this video. So this is going to be a talk called Banishing Loops with Functional PHP. It's a talk I've given a few times, made a big impact on a couple different people, and a lot of people have gotten a little benefit from it at least. You can find me online just about anywhere. Specifically Twitter is my favorite social media, but I'm David B. Hayes just about anywhere I can get it, which excludes Facebook, but includes most anything else. I also run a site called Thoughtful Code where I talk about this and other similar concepts on a pretty regular basis. You may actually be seeing this video there. So, to begin, I've got three basic goals for this talk. One is that I want you to understand what functional programming is. It's kind of a academic thing that a lot of people who, like me, came up kind of out of self-education, or even some people, slightly less likely, who actually went to, say, a boot camp rather than computer science departments, may never have been exposed to this concept at all. What we're going to talk about mostly is practical substitution, so we can make in our day-to-day PHP code using the principles that come from functional programming, and why those changes that come out of functional programming can be beneficial. What benefit we get from those changes is kind of where we get practical and understand the benefit of this. Functional programming tends towards sort of being esoteric and academic, and so I want to, as much as possible, keep us focused on why changes are beneficial. So I like to think about when we all started programming. So for me, this started when I was pretty young. I was lucky to be exposed to programming at an early age. I was actually doing some Lego logo, which is a thing that kind of predated Lego Mindstorms. Lego Mindstorms is, I think, still the current standard that Lego has, but Lego Logo was based on a Logo programming language. But I didn't understand what Logo was. I didn't understand how it fit in the hierarchy of programming languages. I just wanted something to work. I wanted to make my little washing machine agitate. I wanted those sorts of things. And that's really where we all start in general. Some people maybe start in a programming class, but I think most people start kind of self-educated and just wanting the thing to work. So when you're just writing code, it's pretty easy to just be like, blah, 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 this worked, oh my gosh, it worked, and then move on with your life. But as it goes on, as you write more code, and then are tasked eventually with maintaining that code, you learn that the maintenance is actually often the hardest part of code. Rather than being a problem to get functional code in the sense of working, you instead struggle with oh, I have to add a feature. Oh, this doesn't work actually when I thought it did, kind of stuff. You do a lot of debugging, and that maintenance is often ends up as the hardest and least pleasurable part of most people's jobs. And so the hard question that I want you to sit with a little bit while I go into a very different topic is, why is maintaining that code hard? Maybe you've already got an answer. Maybe one will come to you as I talk. Maybe you won't come up with one, but just think about that for a while, because that's not a question we ask ourselves a lot. We just kind of dread it without asking ourselves why. So as I think about it, when we talk about programming today, we typically think about there being three what I would call paradigms of programming, and these kind of break down into different ones, and there are other ones besides these, but as I think about it generally, when we say programming, we typically mean in things like Python and PHP and Java and those sorts of languages, and when we do that, we typically are going to encounter three different paradigms in different classes and languages of code. So the first paradigm that I think of is what I often call procedural. Some people will call it imperative. Some people will insist that there's a nuanced difference between those two things, but I think they're pretty close to each other. And in procedural or imperative code, you're telling the computer exactly what to do. You're telling it to create a variable, to iterate that variable, to then, while iterating that variable, do these other steps in between. You're doing it exactly stepwise. This is what you should do, then this, then this, then this, then this. And that is procedural because I've written that procedure that the computer should follow. Obviously, I've not actually told this silicon current to run this way or anything like that, but I've gotten as close as I can in a high-level language like PHP. When you write code this way, one thing that tripped me up when I started is you can have functions in what is effectively procedural or imperative code. The difference is then that function is really like a stored procedure. It's a procedure that you want to be able to call multiple times and places, rather than being a function in any functional programming sense that we'll get to in a bit. So procedural code is really about storing procedures that you want to do and then executing them by running your program or by running specific function calls inside of your program. This is kind of where most stuff starts. This is certainly how I thought of my Lego logo stuff way back in the day, 20 years ago. The next one is what we call OO, or object-oriented, or OOP code. An object-oriented code is basically built upon the understanding that I've got a lamp right next to me on my desk, or I've got a microphone in front of me and a keyboard in front of me. I see the world, when I look at the world through my eyes, there are colors there. There are like more primitive things than the microphone. But I think about the microphone. I think about the lamp. I think about my keyboard. And I understand that as a unit, and that thing has certain behaviors. My keyboard can give my computer the direction to change the slide or something like that. So we're using in object-oriented programming, any way you slice it, any language you do it, anytime you say object-oriented, you're using that human understanding of objects to try to group your system into reasonable things that a human brain is used to thinking about. So it's a little hard because obviously your keyboard is a physical device and makes sense as a physical device, whereas a email notifier maybe makes sense as an object, maybe doesn't. You can have endless debates about that, and they're worthy debates to have. But really that is what I see as the heart of object-oriented code, is that you're grouping like functionality, like procedures into a single object. So in PHP and most other languages, you will use the term classes, which essentially define blueprints for what we might call instances of objects. So hopefully all that terminology is already familiar to you, and I'm just refreshing you on it. But if you've never heard it before, you'll often hear those things used in object-oriented code. All right, the final one is what I would call functional code, and that's not code that works. Hopefully that's obvious, but is instead the paradigm of functional programming. And in a similar way that object-oriented grew out of the inherent human understanding of structures, of like aggregates of objects, like a lamp or a keyboard, functional code grows out of mathematics, and you're thinking about mathematical type functions in it. The idea there is that those functions have magic properties that make actual programs written using their properties better. So often when we talk about functional code, functional programming, we're dealing with what we call pure functions. And these functions are considered pure because of their similarity to mathematical functions. F of x equals x squared, something like that. And because of their resemblance to that mathematical function, they're more unitary than things like procedures. And they're more pure in the sense of only doing one thing than an object will be. So pure functions, as we talk about it, are mathematical-like, and they are the heart of functional programming. And they are stateless, and they only create their output. They don't have what we often call side effects. And we'll get into all of that in a little more detail in a sec. So getting into a bit more depth about what I mean by the side effects, what I mean by the unitariness of them. Pure functions read only their inputs. So f of x is basically taking as an input x. If you're not very familiar with that kind of mathematical speak, y equals x squared. In that kind of relationship, we know that y is a result of only x. And when we say f of x, we're just saying that this is a function that only involves x. Only x varies here. So x is the only input to this function. And then we do a specific thing, in this case that I keep saying, x squared. We square that number. We raise it to its second power. We multiply it by itself. However you want to talk about that, that is what a pure function is. F of x equals x squared is a pure function because only x goes into it, and only one value, the f of x, comes out of it. So they only affect their outputs. The function y equals x squared or f of x equals x squared does not mutate a hard drive, does not store a value, does not send a message via email. Nothing else happens in a pure function. Only the input goes into it, and only an output or many outputs comes out of it. Nothing else is happening but inputs and outputs, inputs and outputs. And so by only touching inputs and outputs, pure functions have certain limitations. They don't change a database. They don't create files. They don't know what time it is unless you pass it into them explicitly. They don't have any awareness of the system in which they operate. If they are truly pure functions, they must be abstractly true on their own, independent of any functionality. So being totally stateless also means that functions are what we call idempotent. Idempotent, I never know how to pronounce this word. I refuse to learn how to pronounce this word because it's a silly word. But this is a word you'll hear in computer science circles somewhat frequently. And if I could distill it down to a quick summary, it is that I call a function 1, 2, 10, 10,000, 10 billion times, and only one impact changes. So it's as if even if I call it 10 billion times, the result variable of that function will always be identical. What this means is that it can't be time dependent, it can't be hard drive dependent, it can't be database dependent, it can't be dependent on anything else but the inputs and outputs of it. So idempotency is something that people often strive for in object-oriented systems, for example, because it gives you a reliability of it doesn't matter if this API gets hit 10,000 times, the result will always be the same on the 10,000th and one time. Struggled on those words a bit. The other property of this, which we aren't going to get into in a lot of depth in this talk, but really starts to trend you towards the more complicated and interesting sides of functional programming, is that you can compose functions. So if you're now familiar enough with the f of x terminology, if you remember that from high school or college or whenever you might have taken a class that talked in that way, you can compose f of x and g of x to create a new function that we might call h of x. And this is a really important feature of functional programming. It's where a lot of performance benefits come from. It's where a lot of thought benefits come from in it as well. So basically, what's really beautiful about a pure functional programming system is that you can rerun any function, and so long as you know just what it was called and what it was called with, you can find out its error cases. You can find out why that value was wrong, because all you need to debug is that. Certainly, probably, if you've been a programmer for more than a year, you've at least once had this situation where someone reports a bug with some code you were involved with, but it required that you get a database that looked like their database, or a file system that looked like their file system in order to replicate it. And that is something that in a pure function only system, you don't have to worry about. You will just be able to say, oh, you put this file in, oh, this came out. Or, oh, you put in these 5 variables, this came out, and that's wrong. So, really quickly, I like to give you some context for functional programming languages that you might hear conversations about at other programming conferences, on the internet, those kinds of things. Haskell is kind of, as I think about it, the big daddy or big mama of functional programming. It is the purest, functionalist, most beautiful and elegant language to most people who get really into this stuff. I've played with it very little, as is true of most of this list. Elm is a pretty... I think its huge surge of popularity has waned, but it is a language that is built with Haskell and is targeting creating JavaScript. And it is the next best thing, I think, to Haskell. People who I've talked to who've used it love it, swear by it, and especially love its error messages, which is a unique thing in the world of programming languages, that, oh, the error messages are so good. But some people swear up and down that that is one of the best things about it. Clojure is a JVM-based language, which means that it interacts with Java. Java is one of the purest object-oriented programming languages in the world, to my mind. Clojure interacts with the Java system, but lets you write functional programming type code on it. Similarly, Scala does, and I've seen fights on the internet about Clojure versus Scala, which is purer, and that Scala is less pure. I'm not going to take a stance on that. I've not written enough of either to have a strong sense on it. But lastly, I'll mention that JavaScript is kind of a functional programming language. It's got a couple things where some people will insist that it's all functional programming. Most languages, PHP included, are what we would call multi-paradigmatic. They support different ways of writing code, and JavaScript is no exception to that. So let's get back to PHP. So I would say that most classic or legacy PHP, by which I mean especially code that targeted PHP below 5.2, is what I would call procedural. WordPress is the example that comes to mind. PHP 5.2 still can run WordPress as it's written today. And whether you think this is a great thing or a terrible thing, it doesn't really matter. WordPress is able to do that because it contains a lot of procedural code, because the object-oriented systems of PHP today don't quite work down on code that low. I would say that most modern PHP code that I hear about, that I write myself, is object-oriented. So it targets mostly object orientation. And that means that there are a lot of objects in the system. Sometimes I think we're approaching the worst parts of, say, Java, and net factory bean, blah, blah, blah. But object-oriented code has huge benefits. As we talked about, it's easier to think about when I'm just seeing the 8 objects in the system interacting rather than having to remember all the procedures. But some object-oriented code being written today still has a lot of procedural stuff inside of it and doesn't get all the way to, I just can think about this object interacts with this object by sending this message, and therefore this happens. There's a bit of a in-between there, but very little PHP code, I would say, today gets into the functional paradigm. And the primary reason for this is for each, which is a function or a language construct. I'm not actually sure quite which. I'm sure someone will correct me in the comments. I love for each. And it's, to my mind, one of the reasons that PHP is such an effective language is that you can just write for each loops, for each through arrays, for each through objects, for each through associative arrays, for each through non-associative arrays. Like, we can just do all of it in PHP because of arrays and that kind of construct of something being iterable. So we iterate over a lot of things. And for each, to my mind, is fundamentally a procedural concept. And this is the heart of where we're going to get practical. For each is the thing that we are doing in a lot of PHP code that makes it a little bit hard to think about, a little bit hard to understand. Even inside an object method, I think for each means you're writing procedural code. So this is super, super common PHP code in my mind. We create this array called saved, and it's empty. And then we take an array that already pre-exists above this code, and we iterate through the items. We cycle through them as item, and then we select based on size, and we put them into a saved array. And then we're going to display some titles. So we create a new empty array called display titles, and then we for each through the the saved items to pull out the display titles and add them to it after we've capitalized them, because we want to make sure that it all looks correct. And then we're going to iterate through those display titles, that array that we've put together, and we're going to show each items of it. This is so common in PHP, and it's very, very, very effective. I like to joke that I cast for each, it's super effective. One of the reasons that PHP contains so much for each is it gets us through so many problems that we have in the day-to-day work of computer science. Not computer science, very explicitly not computer science, but in web programming. It's super common that we need to iterate through something and get a result and use that result to do some other thing. That's the way that a lot of web programming works, and that is why in PHP we do this so much. What we're going to get into now is how functional programming can help you use for each less and what benefits that can give you over time. So to understand this, we have to understand kind of what I think of as the two fundamental parts of functional programming in PHP. And they are a concept called map and a concept called filter. And these are high-level functional programming concepts that you will see in Haskell and in Elm and in Scala and in Clojure and in JavaScript and everything else that has the ability to write functional paradigm-based code. So what map does is it transforms each entity in a list using a given function. And I made sure to use the word list rather than array here, because this exists, again, across every functional programming language. This is a common function that you see in functional programming languages. Sometimes people can get a little confused by map, so I've heard people recommend that you can think of map as multiply apply, so apply to every item in this set. Whether or not that's useful to you is up to you, but basically you're applying the same transformation to everything in a set. Filter is kind of contrasted to that, because instead what it does is, as you might guess, it narrows down a set of things. So what happens in filtering is that I exclude some from a set and I include others in a set. Typically with filter, again, anywhere it's applied, the filter is actually a positive filter. So I'm filtering out the ones I want to keep from a set. And so basically what I do is I create a criteria, and we'll get into what this practically looks like in code in a sec, but I create a criteria, I give that criteria to filter, and then it gives me back the set from a list that just has the ones that matched my criteria. That's the heart of what filter is. So let's get practical and look at what functional programming in PHP actually looks like. So let's start with a function called ArrayMap, which, as you might have guessed, is an instance of this map concept being applied in a language, in this case PHP. So what ArrayMap does is it takes as its first argument what we often call a callable, and we'll get into what that means in greater detail in a sec. We can briefly understand that as a function. And then the second thing is it takes an array, and that is the array on which you will perform the map operation. So it's that list, that set, that we're going to map over. So if I create a starting set or list, which is an array of the numbers 1 through 5, and I run a map call on it where the first function is a doubling of it, that's what the $i times 2 is. Note the return. So that function returns the transformation, the transformed value. And so what'll happen under the hood is that PHP will take that array and call, well, I take 1, I multiply it by 2, I'm returned to 2, I put that in an array. I take 2, I multiply it by 2, I'm returned 4, I put that in the array, and so on. So I end up with an array that goes 2, 4, 6, 8, 10. So what the array map transformation lets us do is skip over a for each. So this code is basically doing the same thing we just did, only without using array map, but instead using for each, which you probably are doing. So in this case, I created 2 arrays just because maybe something went wrong and I wanted to have it, and then I shoved into the end array the values from the start array as I for eached over them. So that becomes this code right here. You'll notice no line savings. We're just basically getting something that is a little potentially simpler. It's definitely different. We can be sure about that. We'll talk more about the trade-offs and why this could be or couldn't be simpler in a sec. So similarly, we have in PHP an easy way to do a filter operation like you do in many functional programming languages. And that is an array filter function, and its first argument is an array, and the second one is a callable, again, which we can basically understand as a function. So we take an array that has 1, 2, 3, 4, 5, and 6 in it, and we call array filter. We pass in the array as the first argument, and then we pass in a function that will do a modulo equals 0, which is a way you very commonly see to select evens only. Modulo is farther up in the mathematics side of thing. I think by now most people who've been exposed to web programming have done it to like stripe a table or something. But basically, we're only going to see a true value for I modulo 2 equals 0 when the value is even. So we're only selecting out the even ones because our function only returns true on even numbers. So given that, we get out an array at the end that is 2, 4, and 6. All right, so basically we can take this code where we have a start line, and then we create the even array, and then we for each, and then we if, and then we shove into the evens array only ones that matched a certain condition, and then we close our brackets. So you'll note for each followed by an if is a good sign that you'll use array filter in the future. So again, we transformed that code, that for each code into just these 4 lines. So here we're actually getting a line reduction. So it's clearer the benefit if we just like conciseness in our programs. If we just want them to be briefer, array filter already saves us some lines, at least if we write our code in a legible, adhering to many style guides way. I think it's useful to understand callables in a bit more depth just because there are different times when you might need to do it. So first we've got simple function declarations which can yield us a callable. The function hello passed in a name returns hello concatenated with the name. And so in PHP, I just write echo hello equals David. This PHP word is supposed to be hidden, but for some reason my slide deck is showing it, and I'm going to keep rolling with it. So anonymous functions can also be saved to variables. So I can actually say $hello, and then save a function into that. And that will be callable as well, just the same way, only because it's a named variable with a $sign in PHP, I call it by using that $sign in front. It's the only thing that's changed here. All right, so you can also have static methods on your classes. And this is something that, again, as you get into the weeds of OOP, people have lots of debates about. But if I have a public static function hello on a class called namer, I can create a callable by saying echo namer double colon hello, and that will then be callable. Objects can have methods, and then an instantiated version of that object can be used as a callable. So if I have a namer class which has a function hello, it's not a static function, then I need to new up the namer and pass in to my function the namer variable, which is that object instantiated, and then call hello on it. So all the forms of these, the syntax that I've got here, can be used with array map, as we just went over on the last slide. So if I new up an array with some names, I can call hello an array map on a hello where I've just defined a function by saying function name, parameters, etc. That would work fine. Similarly, if I'd stored that function, that hello function, into a variable, then I can call array map that way. If I have a static function, I can pass in a string, or I can pass in an array of the function, the class name and then the static method name. Either one of those call a static method. And then finally, I can pass in to an array map an instantiated object and the name of the method that I want called on that object with an array. All of those work the same with array map or array filter. The other thing I need to go into in terms of details of PHP programming is what is called use. And this gets into a discussion about variable scoping. So variable scoping is kind of complicated and something that we often can glance past in PHP, but in this case it matters a great deal. So PHP today, as I record this in 2018, and really for the last 5 or 10 years, has very, very, very much discouraged the use of global variables, but still supports them somewhat. So the way that looks is that I can have a non-local variable. I can define a callable function by saving to a greater than function, a function, and this non-local variable is not going to be defined the function. This code will not work, as it says across the top of my screen, because in this context, PHP will say non-local is not defined on this line because we're calling the greater than function and it's referring to a variable which is outside of scope of the greater than function. That's all the terminology there. So non-local is defined before the function is defined. The function then does not know about the non-local variable. We call it, we get an error. This also doesn't work. So PHP has had this global keyword for a while. If you've worked especially in legacy PHP code bases, you've probably seen this keyword, but hopefully you haven't needed to understand it in great depth. So a common thing that you might try if you're brand new at this is well, I'll just add this global word in front of the non-local variable and then I'm set. But PHP doesn't actually work that way. It still limits the scope of the greater than function to just the stuff that is inside of it. And so I haven't imported, so to speak, that non-local variable in there. And so again, I'm going to get the same type of error, non-local is not defined. But this works. So if I define that non-local is global at the top level, still, we've just kept that there. But I also define inside of my function that is a callable, that I'm using that global name non-local. Then this function will, all this code will work correctly. But it's not the best way to do it. You want to use the use keyword that PHP provides, and that looks like this. So I define a non-local variable, note I've omitted the global names anywhere. And so I'm defining the function, and then after the parameters to the function, I put the use keyword. And this looks a little weird to a lot of people the first few times they do it, maybe the first couple dozen even. But what you're doing is you're passing in first you're naming first the parameter or parameters of your function, and then you're defining in one or multiple variables that aren't local to your function that it needs to have access to. That's what use means. I want you to have access to this. Use this value inside of here. Use this object inside of here. That's what use is doing, and this code works, and I find it much more readable, especially after having gotten used to that use keyword, which does look a little weird if you're not used to it and you're mostly seeing PHP 4 type code. All right, so this matters because all of this, as I've said, leads to the callable working. So we are able to use array filter and array map with our function where we're accessing this non-local to the function variable if we're using the use keyword. So to streamline it completely, I can actually define the function and the use keyword all in one. No need to have that temporary variable of the greater than function. No need to define the 7 or anything else. This is all working code. And this is where you start to realize the power of functional programming applied to your existing PHP code base. So what we're going to do real quick is run through this code that we started with. So we talked about a save with a for each and an if, where we were trying to decide to only get the big items, and then we were running through the titles and we were capitalizing them, and then we were finally showing them. Let's refactor that using what we've just learned. So we come in here and we can put filter in place of for each. So I mentioned that, to go back one slide, this for each followed by an if is a good sign when I'm looking at code, when I'm looking for improvements in the way of using these functional programming concepts. A for each followed by an if is a really good sign to me that there is a array filter type operation available. So if I do that here, the first line gets rid of the need to have an extra line for that for each, and instead we just put in that array filter in that function where we're passing in the 5. Similarly, we can use map for the capitalization. So we've got the save variable, we use the array filter, we display the titles coming out of the array map, which is just doing that UC first. We're taking that body of the for each loop and putting it inside a function and an array map or an array filter. Pretty clearly. I didn't go ahead and replace the somewhere else you're going to for each, because I think that's probably going to be a template. Hopefully you're using a templating language, and for is kind of a necessary and useful construct in a lot of templating. So there's some downsides to what we just did. The first one is that we had to have temporary variables at every step. And this is just the nature of array filter and array map in PHP. You just have to do that. The other thing that got you, which I've glossed over mostly until now, is that array filter, I believe, I might get this wrong, but array filter takes an array as the first argument and your callable as the second, and array map takes a callable as your first argument and an array as the second. You can kind of keep track of that via rules that people will tell you, but I just think it's hard and unnecessarily hard. I have gotten it wrong probably at least 24 times in my time writing PHP. I wrote out the code from memory without checking whether it was a callable, array callable, and it was backwards. So it's a hassle, and I'm not going to deny that. I'm not going to argue with you that it's a hassle. It totally is. So there are ways to solve those things, though, and that's what we're going to get into next. So generally, there's a class of solutions to this called collection libraries, and what they do is they impart a little bit of this functional programming power to your objects. They create what's called a collection object, in that object then lets you call these concepts again of map and filter without needing to use PHP's specific array filter and array map functions. So there are a lot of them, and what they do is they make it easier to streamline map and filter calls. The big reason for them, like I said, is that array map and array filter have this kind of another place this pain exists in PHP is around haystack and needle and search operations, but they have this kind of argument order issue, and they also just don't read super cleanly when you use array map and array filter because you need to create these temporary variables along the way. I still use them sometimes, but I prefer collection pipelines anywhere I can. So it's somewhat easier to read a collection pipeline syntax than it is to do array map and array filter. Because if you try to nest these, if I want an array filter followed by an array map, all code, including in PHP, executes inside out, but humans read left to right. So this is one of the downsides, is that I'm having to, if I do actually nest these to avoid the temporary variables, I have this backwards reading issue, which is not a huge issue, but it's definitely an issue. It definitely is a cognitive load for you. You also route around the argument order issues entirely. No need to remember the array goes first on map, second on filter, or the opposite. I think it's the opposite, which I'm kind of trying to prove my point, but you don't have to remember that. You don't have to worry about it if you use these collection pipelines. And the last thing is, most of them will give you a fluent interface. So chaining is going to read left to right, in this beautiful way that you never need to create a temporary variable, because chaining methods lets us run all the things at once. If you're not super familiar with a Fluent interface or chaining, jQuery is a place where you might have done it before, where you're using that dot syntax in jQuery, very similar to the way you use the arrow syntax in a PHP Fluent interface, and you're able to just continue to do your operation, continue to do your filter map kind of things without needing to save it out. So the beautiful thing about collection pipelines is that a lot of ORMs use them. So if you're using, I know Laravel's has one, I know Doctrine has one, I don't know about other ORMs, but I expect at least some of them do. You might have a collection system built into your ORM, so you can just use any return thing from your ORM as if it were a collection pipeline, and you can just call map and filter on it. We're going to get into actually seeing that. So this is a set of example code that uses a literal Laravel collection. And so we're going to assume we've done the query using our ORM from the framework we're using. And basically in this system, this theoretical system we're building, posts have scores, comments have scores. We have some system that can tell how good a comment is, how much it reads like English. I'm not in charge of that. I'm not a data scientist, but our team has one. And then what we're trying to do is test hypothesis about, well, good posts are more fluent or the opposite. So what we'll see here is a need for basically a data pipeline for some data analysis, which is one of the places that functional programming gets applied a lot. And we're going to just use Laravel collections to refactor some code. So this is the code without functional programming involved. So I've got a posts value, and I said posts all, which is the way in Laravel I just get all the things. As you might already recognize, I've got a couple for eaches in this code. And this is what we're going to change. So we're running a for each of the posts, and we say if the score is greater than 500, put it in a set. And in that good post set, and then I'm going to pull off the good comments. And the idea is I'd run this, 3 or 4 times to get all the good posts with good comments, all the bad comments on good posts, on all the bad posts with good comments, etc. And then I would be able to do my analysis based on those sets of data. So in the end, we're ending up with a scored good comment set that has a score, a fluency, a comment, and the post itself embedded inside of it. And I'm just storing that somewhere for later use in the analysis chain. Maybe I make it exposed to a REST API, it doesn't really matter. This is the code, and we're going to try to make it better using what we've learned so far. So refactor 1 is going to be to take the filter function from our collection pipeline and use that rather than the array, rather than doing a for each. So basically, again, to go back a slide, I have a for each and an if, and I go, oh, I think that's a filter. And so I can eliminate one of my temporary variables, this good post or this posts, and streamline those into a single thing where after I call posts all, I immediately follow that with a call to filter, which pulls out the good posts. Now for performance reasons, I might be doing this in the database rather than doing posts all. But again, we're exploring the concept and how our comments can get better, how our code can get better as a result. So first we filter out all the posts that have a score above 500, and we keep only the ones that have that score above a function. So remember, the value the true or false we return in a filter function is the ones we keep. Yep. So really quickly, I do need to talk about something else. This is a bit of a tangent, but we'll see how it connects. And this is another functional programming concept that we can use in this code, and that is called flatten. So flatten is a little complicated, but basically what it does is it takes an array of arrays and gives us just the contents of the initial array as a single array. So to say that a different way, I have an array that contains an array that says 1, 2, followed by a new array that says 3, 4, followed by a new array that says 5. And the desired outcome is that I have an array that just says 1, 2, 3, 4, 5, rather than an array that has an array that says 1, 2, and another array that says 3, 4, and another array that says 5. So flatten, what that does is it effectively does that. It takes that array of arrays, so that array that has the array that says 1 and 2, and then the array that has, and then the array that says 3, 4, and then the array that says 5, and it flattens that. It brings it all so that it's a single array that says 1, 2, 3, 4, 5 in it. PHP doesn't have a native array flatten function, which is why I didn't touch on this earlier. But many collection libraries will include this function. And it's, again, a concept like filter and map that exists in all functional programming systems, and we're just seeing it implemented on this Laravel collections library. So what I can do here, this is a bit of a jump, but you'll notice the post all filter is the same, but now on the left there, we've got good comments rather than the just the good post, and that's because we're doing a map followed by a flatten followed by a filter. So what's happening is we're first doing that filtering of just the posts with a score above 500, and then we're effectively pulling off from them their comments. So we're getting an array, a set, let's say set instead of array. We're getting a set that contains all the comments, but the comments are in the place where the objects were. So you'll effectively have a new collection in this actual system of Laravel. You'll have a new collection sitting where you previously had an object. And we're using flatten to then take that collection and turn it into a flat set of just the good comments. And then we're going to filter those to only get the good comments from that set. So we're mapping, then we're flattening, then we're filtering. This is the big jump, and you can make this step by step. The next thing to know is that flat map is a shortcut for the words map followed by flatten. And this is important because you'll notice on that last slide, we had map followed by flatten. So flat map will just let us skip that separate line that just calls flatten. So now we filter, then we flat map, then we filter again. So we get all the posts with good, we get all the good posts, we pull out the comments from them, and then we filter those comments to only get the good comments. So finally, we can take that last for each operation where we're just doing a bunch of stuff. We're setting a score to be available on the set. We're setting a fluency and a comment and a post. And then we're just basically using map to do that all at once. Pretty simple. So did this get better? So this is the initial code we started with. And you'll notice one thing that immediately comes to mind for me is without reading variable names, which, I mean, even if we have good variable names, it's still hard, but if we read variable names, it's kind of clear what this does. It selects good posts, it selects good comments, then it creates a scored good comments set. But you'll notice that the intent here, the fact that we want to get good posts, is kind of getting lost because we have this for each followed by this if. We have this for each with a for each and an if. And so what's required when I look at this code is to think hard about, well, a for each and an if, good posts. Well, good posts, the definition is defined here on this line pretty far down from where we created the good post. And similarly, a good comment is way down here, even though we're getting it on the top. So it's a little complicated. Whereas this, it's very clear to me that I have all of the posts, and then I filter them, and then I flat map them, and then I filter them again, and then I map them. And so conceptually, just by looking over this code, I can read it much more clearly than I can in the other stuff. So I think this is better code. That said, I've been exposed to functional programming enough that I know the first few times you see this kind of code, you will probably be a little lost. You will be a little like, I mean, maybe, but it's hard when you don't remember exactly what flat map is. Maybe you're not even sure what map is. It's really hard to quite make sense of this code. So there is that tax of, this is new stuff for a lot of people who grew up writing procedural code like I did. I remember the first few times I was exposed to this, I was convinced it was worse because it didn't make sense to me, because I didn't know what filter and flat map and filter and map meant. So like this code is simpler in some ways, but harder in others, because you do have to have that familiarity with what filter, flat map, and map mean for this code to make any sense at all. So, you remember that question I asked you early on? What makes code hard to maintain? One of the things I think that makes it hard to maintain is that you have this clutter factor from short-lived variables. Even if you give them good names, as we did in our code sample there, where we had good posts followed by good comments followed by scored comments, you still have the fact that these short-lived variables are kind of cluttering up your system. The next thing is that you kind of lose context when you just see a lot of for each's, and you end up having to think really hard I've certainly done that in my life, thinking really hard what these for eaches mean, because the intent of them, what they're actually meaning to do, is not clear. All that's clear is that procedurally you're going to iterate through things, and then you must figure out what the programmer was trying to do at that point by reading further into the for each and seeing what's going on. The last thing is that deeply nested conditionals really confuse me. And this really gets into indentation level. People often talk about the squint test is one I do, where I squint at the code, like just so I can make out its shape, but not its specific text, and just see how many indents I have along the left side, because that really hurts your ability to quickly reason and read code, which is one of the big reasons that I find functional programming better. So local and temporary variables are reduced, especially when we've got collection pipelines. Because if you remember on that refactoring we just did, we ended up with just the final thing that we wanted to come out of that whole set of transformations as the only variable involved in the system. So we have fewer temporary variables that kind of clutter up the whole thing. By replacing for eaches with map and filter, it's very clear what each previous for each loop is going to do. Because we've eliminated that ambiguity about, well, is this for each going to select things or eliminate things or just transform it in place? All of that becomes clear when you get rid of your for eaches. You also minimize nesting because you're able to use these small single purpose functions. You can kind of look past in PHP, you can look past that function in the name of the variable and just be like, oh, name of variable does this, it's a filter, and kind of read it that way. And when you're reading it that way, it's so much easier to make sense of what's going on. So when I think about this, this line that I initially got from a guy named John Kerry, who's given a talk very similar to this, really struck out at me. And what it is, Jessica Kerr, who was on the Ruby Rogues podcast way back a couple of years ago now, she said that a program cannot change until it is alive in a programmer's head. And that's really where I think the benefits of functional programming come in. It makes it easier for the program to come alive in your head, and so it makes it quicker for you to change your program. Because localizing control and complexity make it easy for you to jump in and out of your code. Because we have busy lives. We have meetings at work. We have the need to run errands during our workday. We have children who maybe, especially if we work from home, will come visit us in the office. Because our office is down the street, or we have kids coming home from school, or we have, the plumber who needs to stop by. Whatever it is, there's so much mental tax in our lives that reducing it by simplifying your code is a huge benefit. So, last real quick thing, can you quickly understand what this code does? Are you scared of it? Does it make you worry? Is this better? I think it is. I hope I've convinced you that it's at least a little better, if not a lot better, and I hope I've gotten you interested in getting into functional programming. So with that, thank you. As I said, I'm David B. Hayes. I go by David in real life, but on the internet it's useful to give that full name because that's where you'll find me on Twitter and many other things except Facebook. I run a site called WP Shout, which is all about WordPress development. So if you're interested in WordPress, getting better at it, all that stuff, please check out WP Shout. And then this talk is based on the work I do at Thoughtful Code, which is non-WordPress, PHP focused, but not exclusively PHP coding. With that, thank you again. I appreciate you taking the time. I know YouTube has plenty of videos that will pull away your attention. Please thumbs up this, thumbs down it, depending on how you feel. And I really appreciate it. Cheers.